Question. Prove this inequality by induction. I answer this question. So, for n equals 1, the left-hand side equals 1 over square root of 1 equals 1. And the right-hand side equals 2 multiply square root of 1 plus 1 minus 1. And this equals 2 multiply square root of 2 minus 1 and equals 2 multiply square root of 2 minus 2. To compare left hand side and right hand side, I can use left hand side minus right hand side. And this equals 1 minus 2 multiply square root of 2 plus 2. We can check this. If this is larger than 0, then left hand side minus right hand side is larger than 0. Then left hand side is larger than right hand side. And this equals 1 square minus 2 multiply square root of 2 plus square root of 2 square. And this equals 1 minus square root of 2 square. And we know this is larger than 0. That means left hand side minus right hand side is larger than 0. Then left hand side is larger than right hand side. So the inequality holds for n equals 1. Now assume that it holds for n equals k. Then we have 1 over square root of 1 plus 1 over square root of 2 plus 1 over square root of k is larger than 2 multiply square root of k plus 1 minus 1. So we have this. We assume this inequality exists. Then for n equals k plus 1, the left hand side equals 1 over square root of 1 plus 1 over square root of 2 plus 1 over square root of k plus 1 over square root of k plus 1. This is left hand side. And right hand side. Right hand side equals 2 multiply square root of k plus 1 plus 1, then minus 1. This equals 2 multiply square root of k plus 2 minus 1. Then I use left hand side to minus right hand side. And this equals 1 over square root of 1 plus 1 over square root of 2 plus 1 over square root of k plus 1 over square root of k plus 1. Then minus right hand side 2 multiply square root of k plus 2 minus 1. And this one is larger than 2 multiply square root of k plus 1 minus 1 plus 1 over square root of k plus 1 minus 2 multiply square root of k plus 2 minus 1. Why the left side is larger than the right side? It's because this part is larger than this part. Because here we assume that this guy is larger than this guy. Now we can check this guy. If this guy is larger or equal to 0, then left hand side minus right hand side is larger than 0. Then left hand side is larger than right hand side. So we check this guy. I write this guy here. 2 multiply square root of k plus 1 minus 1 plus 1 over square root of k plus 1 minus 2 multiply square root of k plus 2 minus 1. And this one equals 2 multiply k plus 1 square root minus 2 plus 1 over square root of k plus 1 minus 2 multiply square root of k plus 2, then plus 2. And minus 2 plus 2 are cancelled. Let's go ahead. And this equals here. For the first term, we just multiply k plus 1 square root of k plus 1 on the top and bottom. Bottom also k plus 1 plus this one, copy the second term here, k plus 1 1, then minus square root of k plus 1 here, 2 multiply square root of k plus 2 multiply square root of k plus 1. And this equals, we put them together, square root of k plus 1. And here, it's 2 multiply k plus 1 plus 1 minus 2 multiply square root of k plus 1 multiply k plus 2. And this equals, it's a square root of k plus 1. Now here is 2k plus 2 plus 1 minus 2 multiply square root of k plus 1 multiply k plus 2. And this equals bottom square root of k plus 1. On top, here is k plus 1 minus 2 multiply, like here, k plus 2. Now here, plus k plus 2. So here is 2k. We separate 2k. Here is 1k, here is 1k. And here 2 is here, 1 is here. Now k plus 1 equals, we can write like here, square root of k plus 1, then square. And k plus 2, also square root of k plus 2 square. This equals, so we have the formula, a square minus 2ab plus b square equals a minus b square. So from this formula, we can get square root of k plus 1, and the top is square root of k plus 1 minus square root of k plus 2 square. And this one is larger than 0. From this one, we know that left hand side minus right hand side is larger than 0. Then left hand side is larger than right hand side. So the inequality holds for n equals k plus 1. Then conclusion, the inequality holds for n equals 1, and if it holds for n equals k, here k is larger than or equal to 1, then it also holds for n equals k plus 1. Therefore, 1 over square root of 1 plus 1 over square root of 2 plus 1 over square root of n is larger than 2 multiply square root of n plus 1 minus 1 for all integers n is larger than or equal to 1. By the principle of mathematical induction,